All right, welcome to Chapter 6, Section 1, Translations. This is for Math 8. So a couple things you'll see on your screen here. The first thing you should see is a due date. I don't see that on the teacher preview here, but you'll see it on your student side. The second thing we see is the number of attempts. You always have unlimited attempts for tests, quizzes, and homework assignments. This tells you the number of questions on this particular assignment. And then we have the grading policy is always best score, meaning whatever attempt is the best one is the one you keep. And partial credit's enabled. So if you answer 1 of 6 questions correctly, you get credit for the 1 question, or however many you answer correctly. Down here it says, please remember, once you start your homework, you must finish it before you can work on anything else. And what that means is once I click the start button down here, in the bottom right corner, we will see a submit assignment button. We want to make sure we always click that button when we're ready to leave this screen. So whether or not we've started anything at this point, or just a couple, or maybe we've done them all, whenever we're ready to leave, we do not close the screen by clicking this little X or just closing our computer. We click submit assignment so that the system doesn't lock us out of all of our other assignments like that front screen just told us. It's going to assume if you don't click that submit assignment button that you want to leave this attempt open. Remember, you have unlimited attempts, so we don't need to leave the attempt open. Click the button. As long as you have green check marks on these that you've actually clicked, checked, and gotten them correct, it will not make you repeat them. You just start back up where you left off. The other big thing that the submit assignment button does is it actually affects the grade book. So your teacher can see what you've been working on. Until you click that button, your account's basically paused. We don't get to see what you've been working on. So, good habit, always click that button. Okay. On the side here, we have explanation, example, and message center. So explanation tells us we are going to lose our current question attempt because it's literally going to explain this problem. It's going to give us the answer. So we're not going to get the answer and then get to come type it in here. Sorry, that's not how this works. But you can look at an example, and this is, completely free. It doesn't cost you anything. You can read through, and as you can see, I have some of these diagrams off to the side here so we can take a look at what they all are. And it'll walk you through a problem just like the one we're looking at. And all we're going to do is decide what kind of translation or transformation this is. And I'll go through that in just a moment. You can click on this for another example if you'd like. And you can also message your teacher directly from the screen. It'll attach a picture so we know where to come help you. All right, so let's go ahead and get started here. So the first thing we want to talk about is what is a transformation when we're talking about a transformation. So specifically for this chapter, we're going to focus on what's called rigid transformations. And that means that we're not changing the size of the diagram or the figure. We're just moving it around the screen, really. So there are 3 types of rigid transformations. We have translation, we have rotation, and then we also have a reflection. So if we look over here, we have these 3 here. So we can flip, and I know, I need to bring this down a little bit so I can, I need to bring the pen size down so I can actually write in there a little bit more. And I think I might also make this a little bigger. There we go. So we can flip one figure over the line shown to get the other figure. So this is called a line of reflection. And we're just flipping it over. And either I'm going from top to bottom or bottom to top. It's not really telling me which way, but I'm flipping it over like a mirror image. So we call this a reflection. If it's basically flipped over, it's backwards. And if you can think of a mirror image, if you look in the mirror, your image is backwards, right? So that's a really easy way to remember. A reflection in a mirror is a mirror image. All right. This one down here, so you can see it's just got an arrow here, and it looks like I took this little mountain shape, whatever this is, and I slid it right down to the other one. So that's exactly how we can describe this, is we can slide one figure to get the other. And a slide is called a translation. So that's specifically the name of that. When we slide things up, down, left, right, it's called a translation. We can do more than one at a time, so you can slide it down and then we could slide it over and we would just have this other shape, and I know that's not perfect, but you can do more than one translation. It kind of looks like it went diagonal, but it's actually just 2 translations there. And then we also have this shape happening here. So Just because the arrow is pointing this way, I would have actually said it's turning that direction, but it could have also turned this direction. That's perfectly fine. So we can turn one figure around the dot here. So when we're rotating, we're always rotating around a specific point. So usually it's one of the vertices of the diagram, but sometimes it's just in the middle. So like if we were turning around and say this is the point and this is the figure, it would always kind of stay the same distance away from that point, and it would just kind of turn around it. So it does look a little different when it's not attached to the point. But for right now, they're going to be attached to the point. So we can turn around and we call this rotation. Oops, that should be an O. Rotation. So we have these 3 rigid transformations. And remember, rigid just means that it didn't change the size or the shape of this figure. All it did was move it. Okay, so that's all that means. So we're just going to go through and we're going to decide here, what are we doing? So on this one, it looks like I'm just sliding this one down. So that's a translation. This one kind of looks like I slid it down, but it is also upside down from the other one. Or if I went up, that one's, the point's coming down instead of going upward here. So this would be a reflection, and the line would be somewhere, right here in the middle, and I'm just flipping it over that line. Same thing with this guy. They're definitely opposites of each other. They're backwards. So that would be a mirror image or a reflection. And this one, hopefully we can see that. There's this little dot here, and it kind of looks like it's spinning around, right? So this is a rotation. All right. So we're going to keep moving here. So the next one has us look at translating a point and giving its new coordinate. So we have 1 step for this one, and the second one we're going to do 2 steps. So this one we're just going to do it in 1 step. So if we're translating a point, it means we're just going to slide it around. We're just going to do whatever it is it's asking us to do on the screen. So the figure below has a point marked with a large dot. So there's the large dot right there. First, translate the figure 6 units to the left. So I'm going to go 1, 2, 3, 4, 5, 6. So I clicked on it, and then that little, you can see how it, like the fist changes to that grab. So instead of it being a pointer like this, it grabbed it and I can move it around then. So you just want to make sure that it's 6 units, and I want to make sure I didn't move that funny. 1, 2, 3, 4, 5, 6. Perfect. So that's 6 units to the left. And so I've translated it. It took the whole object for me. I didn't have to draw the lines separately. It just grabbed the entire object. So it's making it a little bit simpler first. When we move farther through here, it's actually going to make us draw the lines and move every point. Right now, it's just letting us drag it. So the original figure, we want to say, what is this point? So my X is 4 and my Y is 7. So it was 4, 7. My final point, if I look at this one, it's -2, but it's still 7 here. So -2 and 7. So how do these two relate to each other? Well, if I think of 4, 7, and I want to move it 6 units left, left and right have to do with the X coordinate. And left means negative. So left is negative, right is positive. So that means I would move this 6 units left. So I can go like this and add straight down. Well, 4 plus -6 is -2. I didn't do anything to the Y coordinate, so it stays 7. So if you notice, that gave me the exact same coordinate that I arrived at for the final figure. I can do that with the coordinates as well. All right, so let's keep going here. Perfect. All right, we're going to do this next one. It's going to be 2 steps that it's going to ask us to do. So the figure below has a point marked, so we still have a point marked, and wants us to translate it 6 units to the left. So 1, 2, 3, 4, 5, 6, and 5 units up. 1, 2, 3, 4, 5, and then drop it. All right, so I'm going to go, no, I'm not. I don't want to erase the whole thing because that'll erase all my other stuff. Okay, so let's find the original point real quick. So the original point we have here is 1, -8. So we have 1 and -8. So if I come over here, 1, -8, Remember, I can do this with the coordinate as well. If it just wanted to know what is the coordinate without even knowing what the graph looked like or the actual figure looked like on the coordinate grid. If I'm going 6 units left, just like I did in the last one, that's an x coordinate translation. 5 units up, that's a y coordinate translation because up or down is going to be y. So I'm going to go plus 5 units or positive 5, and I'm going to add straight down. So I get 1 minus 6, well that's negative 5. And then negative 8 plus 5, that's going to be negative 3. So let's check to see, is that in fact where it lands? Negative 5, negative 3. Look at that. That's exactly where it landed. So I can do that either way. I can look at the actual coordinate and just say that's where it is. But I can also do this kind of math version, this algebraic version a little bit more, where I'm just adding it to the coordinate or subtracting it from the coordinate and moving it around that way. So remember, left and right, that affects the x coordinate. Up and down, that's going to affect the y coordinate. All right, so let's go ahead and click check and keep moving here. So the next one, we're going to translate an entire polygon. Sorry, undoing. I just want to leave these guys here so we can continue to see that notes page. So it says, draw the following triangle after a translation, 4 units to the right and 2 units up. So one of the main things here, now if you notice, I can't just come over here and click on this. It's not allowing me to do that. I'm now going to have to make sure I move all the vertices the same number of spaces. So I'm going to have to translate each vertice of this triangle, and there's 3 of them. So I'm going to have to translate each one 4 units to the right and 2 units up. So I can take this and I can go from here and I can go 4 units, 1, 2, 3, 4, and then 1, 2. So that's this guy moved from here to here. Now I'm going to do this one. I'm going to go 1, 2, 3, 4, 1, 2. And then this bottom one, 1, 2, 3, 4, 1, 2. And now I have to make sure I connect these because it's going to want to see them connected. So I do have to click on this each time. Boop, boop, like that. So this is translated 4 units to the right and 2 units up. I want to make sure. Those look slightly different sizes. Did I mess one up? 1, 2, 3, 4, 2. 1, 2, 3, 4, 1, 2. I think it's fine. 4, 1, 2. All right. So for some reason my eyes are playing tricks on me. They look like slightly different sizes, like I'd mixed up one of the vertices. But you could also do this the same way, where you have the point. So this would be negative 2, 4, negative 2, 4. So I'm going to add 4. I don't know why I was putting that. I'm going to add 4. So it's positive 4 because it's to the right. Positive 2 because it's up. And so I would have negative 2 plus 4. Well, that's just 2. 4 plus 2, that's 6. So if I look at this, I have 2, 6. That's where this guy landed. So I can do it either way. Whichever way makes more sense to me. If I like just moving it on the graph, that's fine. I have to graph it anyway. So keep that in mind. You have to graph it anyway. But you could also get the coordinates this way and then just plot each coordinate. So again, just kind of makes, whichever makes more sense to you, whichever is more helpful. Let's see, we have 2 more. So we're going to use a transplanted point to find coordinates of another translated, I don't know why I said transplanted, translated point. So now they're not showing us a graph anymore. So we have to understand how to do that without the graph. That's why I was kind of front loading that a little bit and showing you what happens, because I knew they were going to kind of take this away and we were going to have to do it without one. So in the coordinate plane, we have x, which is 1, 1, is translated to the point x prime. So that's what we call that. So it's kind of the original figure and the final figure, and we just do this little mark here. So this is the pre-image and this is the final image. So we want to figure out how far was it moved. 1, 1, and 3, 2, like this. So I'll put these here just for a moment and we'll come back. So under the same translation, the points y, which is 5, 4, and z, which is negative 1, 5, are translated to y prime and z prime, respectively. What are the coordinates of y prime and z prime? So we have to know, well, how far was this one moved? And it looks like both x and y coordinates were moved. There was 2 translations that happened. So we're simply just going to subtract and say, I want to know how far was it moved, or what's the difference? I don't really want to say negative because I went from positive 1 to positive 3. So I need to kind of think of that, and I should have wrote these kind of the other way, I guess, so that the 3 and the 2 were on top. But I just want to say, what is the difference between these two? How far did I move? If I went from 1 to 3, I moved 2 units right, or positive 2. And if I went from 1 to 2, I moved 1 unit up. So, this isn't set up perfect, because if I subtracted straight down, I would have negative 2 and negative 1. I don't want negatives here. I didn't go down negative 2. I actually went up 2. Okay, so just kind of pay attention to that idea. I'm just thinking about, how did I move? Did I go up or down, and how many did I go? So I went up from 1 to 3. I went up 2. From 1 to 2, I went right 2 from 1 to 3. This is right and left. Then I went up 1 from 1 to 2. It would help if I was describing that correctly on the video here. So now for the next one, I'm going to look at y first. So I have 5, 4, and I'm going to add 2, and I'm going to add 1. So 5 plus 2, that's 7. 4 plus 1, that's 5. So this is my new coordinate. That's where it will land when I translate it the same way that I translated x. Now let's do z. So we have negative 1 and 5. I'm going to add 2, and I'm going to add 1. So negative 1 plus 2, that gives me positive 1, because really it's just 2 minus 1. 5 plus 1 is 6. So here's my new coordinate. It's positive 1, positive 6. All right, let's go ahead and check that guy. And yay, we're good to go. All right, so our last one, we're actually going to write a rule for how we translate. A whole lot of undoing there. Okay, so I'm going to keep clicking here while we're reading. So triangle ABC is translated 8 units. Oh, it's going to stop letting me erase. Let's see, can I do this without erasing the entire picture there? Dang it. All right, I need to change the eraser size. Sorry, that's bugging me. I wanted to go away. It only let me undo so many. There we go. All right, that probably would have been easier. All right, so triangle ABC is translated 8 units to the right. So we have ABC. It's translated 8 units to the right and 4 units down. And the result is triangle ABC, I'll just say prime once, as shown. So here's our image, our pre-image, here's our image. So pre-image is where we're starting, image is where we're landing. So the arrows below show that the coordinates on the left are mapped to the coordinates on the right. Fill in the blanks to give the coordinates after the translation. So we have the original coordinates and then the final coordinates. So we can do this. We can either look up here at the figure, or we can just understand it's 8 units right and 4 units down. So if I'm looking at this and it's negative 8 or negative 7 plus 8, that's going to give me positive 1. And 4 minus 4 gives me 0. So if I look at this guy, I have positive 1, 0. Because I moved it 8 units over and 4 units down, which lands right here on 1, 0. So now if I go to B, I moved it 8 units right, so that's negative 3 plus 8. Negative 3 plus 8 would give me 5. And then I was at 2 and I'm going 4 units down, so 2 minus 4 is negative 2. So again, if I check that for B, I have 5 and negative 2. So it definitely works. Or you could just look at this graph and say, okay, what's the coordinate of C? Well, that would be 0. I'm not going right or left, but I'm going down to 3. So it's going to be 0, negative 3. That makes sense. If it's -8 and I went 8 units right, which is +8, -8 plus 8 cancels out. It becomes 0. 3 minus 4 is 1 minus 4 is -3. Jeez Louise, talking too much here. All right, so we do have to choose a rule down here below of what it is we're doing. So remember, each time for the x value, we added 8 because we're going 8 units right. And then each time for the y value, we subtracted 4 because we're going 4 units down. So we just need to match that up where it shows the same thing here. So they all show x, y, x, y. That's normal. If you see one that's yx, oops, don't use that one. That's not our original figure. We didn't multiply by anything, so we're not going to use these first two. We did subtract 4 and add 8, but these are backwards. We didn't subtract 4. We didn't go 4 left and 8 up. So that doesn't work. This is multiplication again, so we're not multiplying by anything. Multiplication or division would show a dilation, which we haven't talked about yet. Dilation is when the object is getting bigger or smaller. So we're not using multiplication or division yet. We'll use that later. I believe that's going to be more in like chapter 7. But right now we're not using that, just addition or subtraction. So over here I can see adding 4 and subtracting 8. Well, that would mean that we're going right 4 and down 8. Right numbers, wrong positions. Although they are backwards because it should be -4 and +8, but still in the wrong positions. So now this is down, or -8, which would be left 8. +4, which would be up 4. Well, that's still backwards. It's not what we did. This is multiplication, so we're going to ignore it. Down here, all right, so +8, that's 8 to the right. -4, that's 4 down. So this is my rule. This is the one that matches. So you just need to make sure they're going to be tricky. They're using 4 and 8 on each one of these. So you just need to go through and make sure which one actually matches what I did. Which one shows that I went 8 to the right and 4 down. So it needs to be in the correct position. You can't just find +8 and -4 somewhere in here because it's in here more than once. But they need to make sure they're in the correct position. 8's being added to the x. -4 is coming from the y. Alrighty. So that was section 1. I will see you in section 2.